You were prepared, maybe even excited, to finally see the image that scientists promised would be the clearest, most definitive photograph of the mysterious interstellar visitor known as 3I Atlas. Observatories around the world, from Hubble and Webb to HiRISE, MAVEN, and Psyche, along with countless amateur astronomers, waited for this specific sideways shot as Atlas glided past Mars. That image was supposed to settle the debate once and for all, but when it finally arrived, the result was a disappointment, a blurry, smeared frame that revealed almost nothing. And strangely, the blur didn't come alone. It arrived alongside a technical report stating that the MeerKAT radio array had detected 23,689 separate radio signals in the 901,670 megahertz range frequencies humans commonly use for phones, aviation systems, and satellite communication. Officials explained that these signals were likely human interference and not spatially aligned with Atlas. But that explanation only raised more questions. If it was just interference, why log all 23,689 events with precision? Why not simply say there was no meaningful detection? Instead, the signals were cataloged carefully and preserved, suggesting they mattered more than officials wanted to admit. And this is where the mystery truly begins. In the gap between what we're told, what is shown to us, and what the data actually implies. One of the most puzzling issues involves the HiRISE camera aboard the Mars Reconnaissance Orbiter. As Atlas passed within 20 million miles, HiRISE should have captured a crisp, high-resolution sideways view much sharper than any ground-based telescope. With its 9 meter per pixel capability, we should have seen Atlas's structure, the shape of its nucleus, the jet formations, and even debris fields. Instead, NASA released a frame so blurry that it seemed artificially softened. The explanation given was spacecraft shake, something HiRISE rarely struggles with. Meanwhile, amateur astronomers with far less capable equipment posted clearer images and time lapses showing distinct jets and unusual color variations. This raised a pressing question. How did backyard telescopes outperform one of the most advanced imaging systems ever put into orbit? Then there are the radio detections. In radio astronomy, thousands of signals in such a narrow frequency band are not trivial. Even if they didn't match Atlas's trajectory perfectly, cataloging them suggests they carried value. The official wording, likely human interference, is cautiously vague. It doesn't dismiss the event. It simply distances Atlas from it. Added to this are intermittent hydroxyl signatures that appeared and vanished, possibly indicating water interaction, chemical reactions, or more complex periodic activity. This kind of behavior is not typical for natural comets and hints at processes scientists don't fully understand yet. Astrophysicist Avi Loeb analyzed Atlas's behavior and identified 12 anomalies that, when combined, challenge the natural comet explanation. Atlas's orbit aligns with the plane of our solar system, which is unusual for an interstellar object. It emits two narrow, collimated jets, one toward the sun and one away, unlike the chaotic jets of natural comets. Its mass and velocity combination defies expectations. Its passes near Mars, Venus, and Jupiter are unusually precise, more like checkpoints than random encounters. Its composition contains excess nickel similar to engineered alloys, yet it contains very little water, which is strange for a jet-producing comet. It shows extreme light polarization, an origin point near the WOW signal direction, brightening and turning blue near perihelion, and jets that remain stable even as the object rotates. None of these traits match ordinary comet physics. Together, They form a pattern that demands deeper investigation. The most serious issue emerges when scientists calculate the energy needed to power Atlas's jets. These jets stretch millions of miles, something natural comets only achieve under extreme conditions. To produce jets of that scale through normal sublimation, Atlas would need to absorb 3 times 10 to the power of 18 joules of energy. That would require a surface area over 600 square miles, meaning Atlas would have to be about 14 miles across. If the jets were driven by water ice, the required diameter would exceed 30 miles. But current estimates put Atlas at a fraction of that size. In short, Atlas is too small to produce the jets we see. The math does not add up. Either the jets have a hidden energy source, or they're not natural at all. This opens the door to alternative possibilities: controlled propulsion, engineered exhaust systems, multiple coordinated probes, metallic structures, or artificial emissions. The official briefing did not address any of these anomalies. Instead, it used reassuring language that described Atlas as behaving within expectations, even though the data suggests otherwise. This silence created a vacuum, one that amateur astronomers quickly filled with clearer images and independent observations. Their recordings revealed narrow jets, strange color shifts, lateral structures, and rapid brightness changes, none of which appeared in the official blurred image. As a result, many people began trusting independent astronomers more than institutional sources. And in many ways, this is a healthy development, because public scrutiny and scientific transparency go hand in hand. What happens next is critical. Scientists need new, higher resolution spectra, refined mass loss measurements, and continued multi-band imaging to check for secondary objects or structures traveling with Atlas. Renewed radio searches could reveal patterns or repeated emissions. Any one of these findings could shift the entire narrative. If the anomalies disappear, we will learn something new about interstellar comets. If they persist, the implications become far more profound. In the end, Atlas arrived as a question, and it remains one. The blurred HiRISE image, the 23,689 radio signals, the extreme jets, the unusual chemistry, and the unaddressed anomalies all point to a mystery that is still unfolding. If Atlas is natural, then we are witnessing a new type of interstellar object that could expand our understanding of space. If Atlas is artificial, then we may not be alone. Either outcome transforms our knowledge of the universe. The key now is to avoid easy answers, stay curious, and keep asking better questions.